studying from the special population of students who come from the office hours. And I'm even going to give you the mean for that group, and I'm going to put that mean at 91. This is all the given information that you will have for one of these examples.
Okay.
I might give you 10 scores and ask you to compute the mean, or I might just say, here's the mean for that sample.
I have a question. For
Yeah.
the test, are we gonna have to like start from scratch, like finding the mean, the z-scores and stuff like that, or are you gonna provide the standard deviation?
For the
For when we do
regression,
for regression.
you're going to have to go top to bottom. They're going to be the simplest possible examples, but
Okay.
you're going to have to go top to bottom. You can do it though.
Yeah.
You can
Yeah.
do it. Okay, so with all this, let's go back to articulating the research and the null hypothesis. The research hypothesis, Emily, is what?
That use of 1 is greater than use of 2.
Mu sub 1 is greater than mu sub 2. The null hypothesis is that mu sub 1 is less than or equal to mu sub 2. Step number 2, the comparison distribution. Comparison distribution, now that we're comparing a mean of a sample, we're going to have a distribution of means. And it's a specific distribution of means corresponding to the general population that is based on an n of 10. Do you remember, the distribution of means has a mean that is the same as the population distribution, but the variance and the standard deviation of the distribution of means gets squishier. The variance and standard deviation reduce as your n increases. So the comparison distribution, I'll put it over here. It's a little bit squished. It's a normal distribution. The mean is mu sub m sub 2. Mu meaning the population mean, sub m meaning of the distribution of means, and sub 2 means corresponding to the mean of the general population. So that's what that symbol means.
So when we add the m, that just means that you're doing the mean distribution.
Yeah, you're going to add the m.
makes sense.
Once your n is greater than 1, that's when you add the m and you're dealing in the world of distributions of means. It equals the mean of the general population, which is 87. Now, the only additional thing is we now need to figure out the standard deviation of this distribution, sigma sub m sub 2. Sigma meaning it's the standard deviation, sub m meaning of the distribution of means, and 2 meaning corresponding to the general population. So the way that this works is
Just want to be in the video.
sigma sub m, sigma square sub m. So first we have to get the variance. Remember, the standard deviation is on the same scale as these scores. The variance is on the squared scale, but to convert this number to this number, we have to go into the world of squared numbers and then back. So sigma square sub m, so the variance of that distribution, equals sigma squared divided by n, which is 5 times 5, which is 25, divided by 10, which is 2.5. I'm going to grab my calculator. So that is 2.5. And so that's not the standard deviation of this, that is the variance of this. It's the standard deviation in squared units. We need to bring it down to non-squared units. So then we get sigma sub m, which equals the square root of sigma squared sub m, which is the square root of 2.5, which is 1.58.
I wanted you to give the square root of 2.5.
Oh, God.
1.58.
I thought you could do it.
Okay, so the standard deviation of this comparison distribution is 1.58. You can see, here's the standard deviation of the population. This is lower. As n increases, that gets lower. So, okay, that's the comparison distribution. That's the only additional thing we've done in Chapter 8 compared with Chapter 9. So look over this math, that process. Ultimately, we're going to figure out this, which is just these simple equations. Step number 3, we're going to get the critical value. critical value is going to correspond to the alpha region. This region is what percentage of the distribution?
1%.
It's 1%. Meaning, hey Sarah, that this is 49%. And this z-score, that what we call the z-critical, that z-score is going to be found from the table. Emily, do you want to be my best friend and grab the table?
Yeah.
Hey, you can walk by.
Sorry.
You're going to be on TV.
What page is it at again?
It's actually marked. It's like folded.
Oh, I see.
There it is. So now, we're looking for the z critical, that corresponds to having 49% of the distribution between that score and the mean. And what's the answer?
2.33.
2.33. And show that to the video real quick. So that we get it from the table. We look at what z corresponds to that particular point. 2.33. The next thing we're going to do, step number 4, okay, now we're going to compare the z that corresponds to this specific mean of 91 to this critical value. So z, or what I call z obtained, equals the sample mean of interest, which we are going to be given at the very beginning, or you might be given a set of scores and you calculated it. So that particular mean of interest minus the mean of the comparison distribution, use of m sub 2, divided by the standard deviation of the comparison distribution, sigma sub m sub 2 equals 91 minus 87 divided by 1.58.
I have a question.
Mhm.
So when we do a hypothesis testing, when it's greater than 1, we need to use this formula for z obtained, because I know when we
Yes.
do z obtained for the other ones, we find the z score.
That's an individual score minus the
And then-
general population
Yeah.
distribution mean divided by this. Yes.
Mhm.
So in other words, whatever your comparison distribution is, then you're going to use that mean and that standard
Yeah.
deviation. If n is greater than 1, these are going to be the parameters for our comparison distribution. We'll use that in our z formula. Exactly right. So 91 minus 87 divided by 1.58 is 2.53 as a z-score. So now we're going to put, if this is a z distribution, that means it has a mean of 0. Here's a z of 2.33 and a z of, this is the z obtained, of 2.53 is greater than 2.33, just a little bit greater, but it's greater than. And then step number 5, we're going to comment on the null hypothesis. And it's a very simple decision. Since it's more extreme than the z critical, we're going to reject the null hypothesis. Supporting the idea of the research hypothesis. So the idea is that a score of 91, a mean of 91 in this distribution of means is incredibly low in likelihood, but if there is a distribution that is different for students who attend office hours, and if that mean is greater than this, then a mean of 91 is actually more typical in that kind of distribution. And that's why we're going to reject the idea that that mean came from this distribution and support the idea that it actually probably came from a distribution that has a mean that is greater than this distribution. That is chapter 8. Peace.